Hello everyone, in this video I'll show you how to plot and animate any kind of math function using the Vinci Resolve Studio 19. First, let's create a new Fusion composition in our media menu. Now right click on our new composition and open a Fusion page. Now in the nodes menu we're gonna need as polygon node and as render node. And now let's connect all three to our media output. In our as polygon node, on the right menu, you can see right click here for shape animation. Right click, remove as polygon polyline. Right click again and now select custom poly. Now we have custom poly in our modifiers menu. Here we're gonna use only the controls menu and polyline menu. In the polyline menu, this is where our magic will happen, like poly expression X and poly expression Y. Since I'm gonna show you the horizontal graphs, then I'll need poly expression Y. If you want to make it vertical, you probably have to use this one, poly expression X. So let's start with something simple, like a sinus wave. First, increase the number of points to something like bigger. For example, 200 is okay. You can go like 300, maybe 500, but keep in mind that Fusion and DaVinci Resolve are not really optimized for this kind of thing. And the more points you have, the more pressure, the more stress it will put on your PC and your CPU, your GPU probably as well. So keep that in mind. In my experience, usually 300 or 200 points are enough for most of the cases. So in our poly expression Y, we're just gonna need py plus sine index. I'll explain this in a bit. Divided by 10. And this divided by 10 as well. Wait, that's too much. Maybe I should multiply it. Okay, yeah. Now let's remove the outliner. You can press Ctrl K. Oh, we don't see anything. Yeah, let's add some border width so we can see our function. Okay, that's nice. And if I press play, nothing happens. It's static. It's not moving. If that's what you need, then you have it. But if you want to animate it, then you can do this thing. Let's add index plus time. Now, as you can see, it's slowly moving from right to the left, like our wave. But we can also do that. Oh, I'm sorry. Multiply by 10. So now we have our wave animated. And here where the controls come into play, basically the controls are the variables that you can use in the expressions, and you can animate or put another like expression on those variables to animate themselves, and this will affect the polyline shape. So how to access them. Basically, the number in 1 is n1, number in 2 is n2, and 3 and 4. It's really simple. Let me show you. Just multiply by n1 and divide by n2. And now in controls, let's set n1 as 10, n2 as 10 as well. And let's hit play. And now when I play around with number in 1, I get basically some kind of scale on x axis, and if I play with number in 2, I get the scale on y axis. So what do those variables mean, like px, py? They represent the coordinates of the point, like the initial coordinates. So this way, px means that we don't do anything to our points on x, they remain as they were. And on py, we just add our function value to our base coordinate on base y coordinate, and therefore we get this like delta and our function plotted. Then index, again, it's a special keyword for this poly expression. It returns the index of the point starting from 0. For example, like, let me show you. This point on the left, the first point, it has index of 0. Like this one, right? Then the next point has index 1, 2, and so on. And we use them to get basically our delta, like our x value, like on horizontal axis. So we can calculate our sinus function in space. And time, well, time is time. Time is this value that is changing when we are playing our animation. Now let's look at another example, like a little bit more complex function, if you can say that. I'll be showing you the vertical impulse. So to achieve that, we're going to use the if operator. It has 3 arguments. The first argument is the condition. The second argument is the return value if condition is true. And the third argument is return value if condition is false. So in our case, our condition will be index plus time in brackets modulus, let's say 20, is more or equal to 10. Then if this is true, we return 1. If this is false, we return 0, and we divide this by 10 again. So this gives us animated, like, vertical impulse, as you can see. And if we replace those numbers with our controls again, for example, let's put 20 in control 1, 10 in control 2, and another 10 in control 3. And now let's replace the numbers here with the variables. And 1, and 2, and 3. Then again, by playing around with those values, we can change. No, it's easy if I pause this. For example, we can change the size of the spike, make it bigger, make it smaller, or the same goes for the other variable. We can change the size of the spike as well. And the last one is just our vertical scale. And by changing the size of the spike, we also scale it on the x-axis. So that's it. And probably the last one that I want to show is how to use random values. For example, if you just want to make some random, like, garbage noise animated as some kind of, graph of some kind of plot input. To do that, we're gonna need the random function based on seed. So let's see, it's called rands. It also has 3 arguments. The argument 1 is the number to generate from. The second one is the number to generate 2, and the last one is our seed. And let's put this in brackets. Let's subtract 10, so we get like positive and negative values. And let's divide this by 10. Yeah, maybe we need to divide this much more, by 100 in our case. So as you can see, our seed is index, and since each point has its own unique index, this means that each point will have fixed random value assigned only to this point. So this is why we have this static image right now. But if we add time, then, well, we get the same effect as we had previously with our math functions. It's moving from right to left. Oh, also, if you want to move it the other way around from left to right, you can use you have to use minus instead of plus, like minus time, not plus time, and this way it will go the other way around. If you want to make it go slower, so right now it's changing every frame, but if you want to make it go slower, like change, for example, every 10 frames or in every 20 frames, you can do this. You're gonna use the int function. So let's replace our time with int brackets, and you write here time divided by, well, let's say 10 again, like, no, let's say 30, every 30 frames. As you can see, it changes only every 30 seconds, like very slowly, very slowly. So what does the int function do? It gives you the integer part of the division. So for example, 1 divided by 5 is 0.2, and the integer part of that is 0. 4 divided by 5 is 0.8, and the integer part is 0 as well, but 5 divided by 5 is 1. The integer part is 1, and so on. Basically, this way our value in this expression changes only every 30 frames. This is why we get this slow movement of our function. And again, you can like replace those numbers with like controls if you want, so you can like animate. And also the last thing that I forgot to show you is that how you can animate your plot, like how it's being drawn from left to right. Let's go back to sine wave quickly. Time, no, like index divided by, multiplied by 10 and divided by 10. Yeah, so our image is static right now. So if you want to animate it from left to right as if it's being printed out, then you just go back to your polygon tool, and there is the slider called length. And by playing around with the slider, you can see it's displaying only part of your graph. And if you animate it, it will give you this nice effect. And if you need reference materials on how to work with this tool in like detail, like with S polygon and custom polygon, first of all, there is always the Vinci Resolve reference manual. If you click it, it will load up for you. In this manual, if you press like Ctrl F and let's write poly expression, you will find the definition for the custom poly tool. Yep. So it gives you like the examples for the variables that can be used. For example, like the index, px, py, like this get x, get, well, I didn't use this. Also, if you want to learn more about math functions, which one there are, which ones to use, you can search for rands. And let's scroll down until you get, yeah, and there you have this nice table at page 2424 with all the math expressions, constants, and Well, functions, also math operators, like the modulo operation, which I used. And there is also a video that I'll link to you and leave link in description. This guy basically explains how to work with this custom poly in general, not just for the plotting graphs, like what, for example, those source polylines do, what those like other uh, functions do that we covered, like disp, getx, gety, this kind of stuff. Be sure to check it out. And that's all from me. Thank you for watching. I hope this helps because, well, turns out that there wasn't any guides on the internet on how to do it. I was kind of shocked, not gonna lie.